What's up, guys? So today we're going to be continuing with scientific notation. All right, we're going to be ordering and comparing scientific notation. All right, so the first one is we're going to be comparing exponents or comparing scientific notation. Okay, so the first way is you need to compare the exponents. All right, so when we compare the exponents, if the exponents are not equal, I want us to underline the word not. If they're not equal. Okay, so if the exponents are not equal, what's going to happen is the greater exponent exponent means it is the greater scientific notation. Okay, so the greater exponent means it's a greater scientific notation. All right, so if they're not equal, whichever one has the bigger exponent means it is the largest number. So for example, let's say we're comparing 2.35. This will be example 1. I'm getting ahead of myself here. Times 10 to the negative fifth. And we'll compare that to 1.49 times 10 to the negative second. Okay? So look at our exponents here. All right? This one has an exponent of negative 5. This has an exponent of negative 2. We're trying to see if these are less than, greater than, or equal to. All right? Look at your exponents. Which one of those exponents is larger? You don't have to take these and expand them out and create the number and then determine. We can just look at the exponents. On a number line, negative 2 is greater than negative 5 because this number is closer to 0 on the negative side, which means this one will be greater because it has the greater exponent, which means it's the greatest number. If you don't know which one of these goes here, remember your alligator. Your alligator eats the biggest number. So my alligator wants to eat this number because it's larger, so we'll use our less than sign. Okay? Greater exponent means it's the greater scientific notation. Now, the other way, what if the exponents are equal? And underline the word are, they are equal. Okay, and these up here, this example is are not. This one is if they are. Okay. The greater decimal. All right, just like here, here's our decimals. Okay, greater decimal equals, that's the greater scientific notation. Okay, so the greater decimal means that one is the greater scientific notation. Here's our example. Let's say we have 3.434 times 10 to the negative 9 and 9.14 times 10 to the negative 9. Okay. So again, we're looking for less than, greater than, or equal to. All right. Now, our exponents are the same, so we can't use this method up here. Okay. We have to look at these two numbers here, 3.434 and 9.14. Which one of those numbers is greater than the other one? Well, 9 is definitely greater than 3. So I don't have to go any farther than that to know this number over here is the largest. I don't have to expand these in expanded form and then compare them. All right. So this one is my greatest number. So my alligator is going to eat that number, so it'll be the less than sign. Okay. It's just as simple as that. If your exponents are not the same, you look to see which exponent is greater. If your exponents are the same, then we go and compare our decimal numbers. All right. Not too bad. Now let's get into ordering. So ordering scientific notation. So there's a couple of different words that we need to understand what they mean. Okay, we need to know what the word ascending. What does the word ascending mean? Okay, the word ascending, this means basically least to greatest. Whoops, I cannot spell this morning. Least to greatest. Okay, so if something asks for it to be ascending order, that means we're looking for least to greatest. If it says descending, like descending as in decrease, okay, this means greatest to least. Okay, so descending, you can think about the word decrease because they sound the same. All right, descending, decrease. All right, and ascending means least to greatest. Start at the smallest and go to the largest. All right, so I will do an ascending example and I'll match it and do it in purple so that way we can kind of match those up there. All right, we're going to order scientific notation in ascending order. And our numbers are 7.4 times 10 to the third, 3.289 times 10 to the 15th, and 4.53 times 10 to the third. So we're going to order these in ascending order, okay? Now, look at these numbers. Use our rules from above, all right? Remember our rules. First, we're going to look at the exponents if they're not equal. Well, we have a 3, a 15, and a 3. Two of them are equal. One of them is not, okay? So we can know, look at our exponents. I know this number right here is largest because it has the greater exponent. That's my largest number, okay? And we're looking for ascending, which means we're going from least to greatest. So this number is definitely going to be last because it's the largest. So I'll go ahead and put that out here. 3.289 times 10 to the 15th. That's last. All right, it's the largest. I know that because I looked at my exponent. Now let's compare these two. Remember, when our exponents are the same, we're looking for the greater decimal. So look at our decimals. I have 7.4, 4.53. 7 is definitely greater than 4. So 7, this will be my second number. So I have 7.4 times 10 to the third, which means makes my smallest number 4.53 times 10 to the third. And we've ordered those in ascending order, okay? Ascending order meaning least to greatest, okay? So this was my smallest, and this was my largest. All right. And we'll look at one more example. So we're going to order scientific notation in descending order. And our numbers are 2.4579 times 10 to the negative fifth, 8.5 times 10 to the negative 12th, and 2.53 times 10 to the negative fifth. So descending order, descending, decrease, greatest to least. So this is going to be greatest to least. So we're looking, which one of these numbers is my greatest number? compare our exponents, -5, -12, -5. Well, two of them are the same. Okay, so by looking at these, I know these two are the largest because -12 is smaller than -5. So this is going to be my smallest number. So I can go ahead and put my 8.5 times 10 to the -12 right here at the end. That's my smallest number. So then let's compare these two. Okay, when your exponents are the same, we go to the decimals. 2.4579, 2.53. My twos are the same, so we're going to start comparing tenths place, hundredths place, and all that good stuff. All right, so 2.5, 2.4, but that 4 can be rounded to a 5. Okay, so let's look at the hundredths place. 5.3, 4.5, that 5 can be rounded to a 6. So 5.3 is definitely greater than 4.6. So this is my greatest number, which means this is my middle. So we have 2.4579 times 10 to the -5th, and my largest number, 2.53 times 10 to the -5th. Okay, so this is my smallest because of our exponents, and this was my largest, and I had to go to the decimals to order those. Okay, so when comparing and ordering scientific notation, all right, check your exponents first. The larger, greater exponent, greater scientific notation. If they're the same, check your decimals. The greater the decimal, the greater the scientific notation number is. Ascending, least to greatest. Descending, greatest to least, means it's decreasing. It's starting at the top and it's going down. All right, and then we have our examples. Make sure you keep working on your IXLs, and if you have any questions, be sure you email me. Hope you'll have a good day.